everyone, myself Dr. Suresh, Professor of Biochemistry, and in today's video, we'll be talking about the aromatic amino acid phenylalanine metabolism. Here, there are three aromatic amino acids: phenylalanine, tyrosine, and tryptophan. So, when we study about phenylalanine metabolism, no need to study separately about tyrosine. Why? Because when you provide phenylalanine in the diet, in our body, once it enters, it will be converting into tyrosine. So that's the reason tyrosine is non-essential. So when you are having any defects in making utilization of phenylalanine, if you provide tyrosine, that will be sufficient. In this condition, like some disorders or disease conditions like inborn errors, suppose phenylketonuria, where person couldn't able to utilize phenylalanine, and because of the absence of some enzymes that we will discuss in inborn errors of amino acid metabolism. In that condition, like phenylketonuria, tyrosine will become conditionally essential. So because here the condition is phenylketonuria. Why? Phenylalanine couldn't able to metabolize properly. So whatever the beneficiary effects of phenylalanine, it all depend on the tyrosine, because the very first step of phenylalanine in our body is to convert into tyrosine. The structural difference between phenylalanine and tyrosine is a phenol group. In phenylalanine is having a simple benzene ring, and in case of tyrosine it is having a hydroxyl group attached to a benzene ring, that is phenyl group. Okay, so that's the reason tyrosine is always having a sparing action over phenylalanine. And when you talk about phenylalanine, the metabolic fate of phenylalanine is two ways: glucogenic and ketogenic. That means at the end, when phenylalanine metabolized, it will form two end products. One enter into glucogenic pathway, other enter into ketogenic pathway. Next. So first we'll see how phenylalanine is converting into tyrosine. Remember here two things: phenylalanine is essential, tyrosine is non-essential. So when tyrosine will become non-essential, when you are providing ample amounts of phenylalanine, then there is no need of tyrosine to be supplied, and tyrosine will become non-essential because phenylalanine is converting into tyrosine. Okay. In case of conditional conditions like phenylketonuria, phenylalanine cannot be metabolized, so tyrosine will become essential. So in case of phenylketonuria, conditional essential amino acid is tyrosine. So now we will study about the catabolism, because why I am mentioning about catabolism, phenylalanine is essential, we are supplying it from outside, right? So for us it's not mandatory to study its synthesis. So we'll study only the catabolic part of phenylalanine. So first step, once phenylalanine enters into our body, it will convert it into tyrosine with the help of the enzyme phenylalanine hydroxylase. Here there is a requirement of molecular oxygen, and it converts into water molecule. Okay, and the requirement of coenzyme here is tetrahydrobiopterin. Okay, so like tetrahydrofolic acid and dihydrofolic acid, this is also one of the coenzyme. Okay, so tetrahydrobiopterin having 4 hydrogens, okay, which donated hydrogens to oxygen and to form water molecule and convert into dihydrobiopterin. And again this dihydrobiopterin accepts the hydrogens from NADPH with the help of the enzyme NADPH dependent reductase, which donating the hydrogens, okay, then converting dihydrobiopterin to tetrahydrobiopterin. And this reconversion is very important. In conditions like NADPH dependent reductase deficiency, there is no regeneration of tetrahydrobiopterin and the reaction will stuck up, and there is no conversion of phenylalanine to tyrosine. So remember, the main enzyme to remember here is phenylalanine hydroxylase. So I told you the structural difference between phenylalanine and tyrosine. Phenylalanine is having a simple benzene ring, tyrosine, addition to benzene ring, it has hydroxyl group. So to convert phenylalanine to tyrosine, we should add OH group to the benzene ring of phenylalanine. So that's what the enzyme is doing, phenylalanine hydroxylase. So phenylalanine converted to tyrosine, and the enzyme is phenylalanine hydroxylase. You see here, this is a hydroxyl group added. So the first step we have completed, phenylalanine hydroxylase converted to tyrosine, and now hereafter the metabolic fate of phenylalanine tyrosine is same. Okay, so tyrosine now converted into para-hydroxy phenylpyruvic acid. Here the amino group from tyrosine donated to alpha ketoglutarate and converted to glutamic acid. You can say it is one of the transamination type of reaction where the amino group is transferring from tyrosine to alpha ketoglutarate and converts alpha ketoglutarate to glutamic acid, and it is a pyridoxal phosphate dependent enzyme. Okay, PLP is a B6 water soluble vitamin and the coenzyme is PLP. The enzyme is tyrosine transaminase. So because of the tyrosine transaminase, tyrosine could able to donate its amino group to alpha ketoglutarate and convert it into para-hydroxy phenyl pyruvic acid. Now again there is one more molecular oxygen coming to the action and causes decarboxylation. Okay, it removes carbon dioxide from the para-hydroxy phenyl pyruvic acid and it forms dihydroxyphenylacetic acid, that is homogenetic acid. Remember this, homogenetic acid. And the enzyme is para-hydroxyphenyl pyruvate hydroxylase. Para-hydroxyphenyl pyruvate hydroxylase. So overall 3 steps to make out. Phenylalanine converted to tyrosine, tyrosine is converting to para-hydroxyphenyl pyruvic acid, and phenyl hydroxyphenyl pyruvic acid is converted to dihydroxyphenylacetic acid, otherwise it is known as homogenetic acid. Now this dihydroxyphenylacetic acid or homogenetic acid, okay, the ring will be cleaved here. Again one more molecular oxygen. So now you can make out, apart from the respiration, the use of molecular oxygen at metabolism level is mainly in aromatic amino acid metabolism. So here itself you can make out, in first reaction conversion of phenylalanine to tyrosine there is a requirement of molecular oxygen, and in the conversion of para-hydroxyphenyl pyruvic acid to dihydroxyphenylacetic acid there is also requirement of molecular oxygen, and again conversion of homogenetic acid to mallyl S2 acid there is also requirement of molecular oxygen, and this conversion requires cleavage of the ring, benzene ring opening. So the enzyme is homogenetic acid oxidase, and this enzyme is crucial, you have to remember. So mallyl S2 acid further converted to fumarate S2 acid, there means there will be structural changes in mallyl S2 acid by the enzyme mallyl S2 acetate isomerase and converted to fumarate S2 acid, and now here this fumarate S2 acid divide into 2 parts. This fumarate part converted into fumaric acid, that means that will enter into TCA cycle, converted to malate to oxaloacetate, and oxaloacetate enter into gluconeogenic pathway, and acetoacetic part converted into acetic acid and enter into ketogenic pathway. So this is overall catabolism of phenylalanine and tyrosine. Total 6 steps are there. If you remember, once again I am summarizing it. Phenylalanine converting into tyrosine, tyrosine converted to para-hydroxyphenyl pyruvic acid. Okay, what is happening here? The amino group from the tyrosine will be transferred to alpha ketoglutarate to make glutamate by the enzyme tyrosine transaminase, which is PLP dependent. PLP is nothing but pyridoxal phosphate, B6 water soluble vitamin, and para-hydroxyphenyl pyruvic acid is converted to homogenetic acid or dihydroxyphenylacetic acid by the enzyme para-hydroxyphenyl pyruvate hydroxylase. Okay, there is a removal of carbon dioxide, and here you require vitamin C. Okay, remember here there is a requirement of vitamin C because it is a strong reducing substance and it is a reduction reaction. Now this homogenetic acid converting into mallyl S2 acid by opening the ring, benzene ring, by the enzyme homogenetic acid oxidase, and here also there is a requirement of molecular oxygen and it is converted into mallyl S2 acid, and there is isomerism, isomerical changes in the structure of mallyl acetic acid by the enzyme mallyl S2 isomerase converted to fumarate S2 acid, and this fumarate S2 acid converted into 2 parts. Fumarate part converted to fumarate enters into TCA cycle and forms oxaloacetate, and oxaloacetate comes out of mitochondria and participate in gluconeogenesis, and the leftover S2 acid enter into ketogenic pathway. So that's all about phenylalanine and tyrosine catabolism. Thanks for watching. Thank you.